Renewable sources of energy, wind power. Wind power plants, or as they are also called, wind electric farms, are several wind generators combined into one chain to generate electricity of a certain power. Sometimes only a wind generator is mistakenly called a wind power plant. This is not the case, since the power station is not only designed to generate energy, it's also important to collect, accumulate, save, and transfer it to the consumer via the connected network. This type of station converts wind energy into electrical energy. History of wind electropower. The first in the world wind power station was the station Ufimtsevo in Soviet Union with inertial battery, which was commissioned in 1931 near the city of Kursk. Today the largest wind electropower farms are located in China, India, the USA, and also the countries of the European Union. Types of wind power plants. Wind power plants are divided into several types. The most common type is terrestrial. The industrial construction period of one wind generator on a prepared site is 5 to 10 days. The largest is the Alta ground power plant, located in the United States, California. It's able to generate power up to 1,550 megawatts. There are also coastal, mountain, floating, and even floating wind power plants.
A wind farm is a group of wind turbines in the same location used for the production of electric power. A large wind farm may consist of several hundred individual wind turbines distributed over an extended area, but the land between the turbines may be used for agricultural or other purposes. For example, Gensu Wind Farm, the largest wind farm in the world, has several thousand turbines. Almost all large wind turbines have the same design, a horizontal axis wind turbine having an upwind rotor with 3 blades attached to a nacelle on top of a tall tubular tower. In a wind farm, individual turbines are interconnected with a medium voltage power collection system and communications network. A wind farm may also have coastal, mountain, and offshore location. Wind energy offers many advantages, which explains why it's the fastest growing energy source in the world. Current research efforts are aimed at addressing the challenges to greater use of wind energy. So there are several advantages of wind power. Firstly, it's a clean fuel source. Wind energy doesn't pollute the air like power plants that rely on combustion of fossil fuels such as coal or natural gas. Wind turbines don't produce atmospheric emissions that cause acid rain or greenhouse effect. Wind energy is a domestic source of energy. The nation's wind supply is abundant. Over the past 10 years, cumulative wind power capacity in the United States increased an average of 30% per year, outpacing the 28% growth rate in worldwide capacity. Also, wind is sustainable. Wind is actually a form of solar energy. Winds are caused by the heating of the atmosphere by the sun, the rotation of the earth, and the earth's surface irregularities. For as long as the sun shines and the wind blows, the energy produced can be harnessed to send power across the grid. Wind power is cost-effective. It is one of the lowest-priced renewable energy technologies available today, costing between 4 and 6 cents per kilowatt-hour depending upon the wind resource and project financing of the particular project. Wind turbines can be built on existing farms or ranches. This greatly benefits the economy in rural areas, where most of the best wind sites are found. Farmers and ranchers can continue to work the land because the wind turbines use only a fraction of the land. Wind power plant owners make rent payments to the farmer or rancher for the use of the land, providing landowners with additional income. However, there are also some challenges of wind power. Wind power must still compete with conventional generation sources on a cost basis. Depending on how energetic a wind site is, the wind farm may or may not be cost competitive. Even though the cost of wind power has decreased dramatically in the past 10 years, the technology requires a higher initial investment than fossil fuel generators. Good wind sites are often located in remote locations, far from cities where the electricity is needed. Transmission lines must be built to bring the electricity from the wind farm to the city. Wind resource development may not be the most profitable use of the land. Land suitable for wind turbine installation must compete with alternative uses for the land, which may be more highly valued than electricity generation. turbines may cause noise and acoustic pollution. Although wind power plants have relatively little impact on the environment compared to other conventional power plants, there is some concern over the noise produced by the rotor blades and visual impacts. The turbine blades may damage local wildlife. Sometimes birds have been killed by flying into the rotors. Most of these problems have been resolved or greatly reduced through technological development or by properly seating wind plants.
The potential of wind power in Kazakhstan is 10 times higher than the need for electricity. According to the experts, now the entire power industry of Kazakhstan is based on coal fuel. This is due to the fact that the country has significant reserves of coal, which is enough for another 200 or 300 years. Thermal power plants, CHPs, produce about 85% of all electricity in the country. 1 kilowatt per hour produced by CHP costs about 6 to 7 tenge. The price is based only on the cost of production, since all the stations were built several decades ago and they do not require a return on investment. However, due to the deterioration of thermal power plants and their low environmental friendliness in Kazakhstan, it is necessary to build improved thermal power plants or switch to renewable energy sources, that is, to wind, hydro or solar power plants. If government of Kazakhstan will install wind farms in windy places, then in total they will produce about 920 billion kilowatt per hours of electricity per year, which is 10 times more than all of Kazakhstan consumes annually. At the same time, the installation of wind turbines will require significant investment. Each kilowatt of power will cost about $2,000 to $2,500. The cost of electricity should be incorporated investment component. The cost here is insignificant, no need to buy the wind, but the investment will need to return. Within this aspect, the cost increases to 20 to 25 tenge per kilowatt hour. According to estimates, at such a price, the investment will pay off within 10 years, and only after that can electricity become cheaper. What's the problem? If you build a wind farm and enter the market with this energy, no one will buy it because it is significantly more expensive. You need appropriate government regulation that will allow to use this energy. This decision is embodied in the relevant laws and in making those goals that should be achieved by the state. In addition, Kazakhstan has voluntary commitments to reduce greenhouse gas emissions by 15% by 2020 and by 25% by 2050. In addition, according to the expert, the state plans to increase the share of electricity generated by renewable energy sources to 50%. The state notes that all regions of Kazakhstan have the potential to build wind power plants. For example, in the Almaty region, wind turbines can be installed in the region of the Korday mountain pass, in the Shelek corridor, and in the Jungarian gate. In total, these three power plants will be able to provide power of about 900 megawatts or 2.5 billion kilowatt hours per year. This would be enough for all of Almaty, given that during peak periods or during windless weather, backup sources such as hydroelectric power stations will be connected to the power supply. Yet it is worth noting that the issue of electricity production in Kazakhstan is quite acute. This is due to the deterioration of existing power plants and a large number of harmful emissions that accompany their work. Naturally, one of the key points for the average consumer is not only the environmental, but also the financial component of the problem. The equipment and debts is borne out by 70%. It needs to be changed. In view of the above, one should not expect a decrease in the cost of electricity. We must prepare for it to rise.
Korday Wind Farm, wind power plant located 30 kilometers from the village of Korday in the Korday region, Jambul region of Kazakhstan. The WPP is located near the Almaty-Bishkek highway. The development of a feasibility study, also known as TEO, construction of a Korday wind power plant with a capacity of 21 megawatt in the Jambul Oblast, was carried out by the Institute Kaz Sel Energoproyekt LLP and completed in 2012. The areas where the average annual wind speed exceeds 6 meters per second were identified. As a result, a decision was made in favor of the site near Korday, since at an altitude of 40 meters according to UNDP, there is wind potential with an average multi-year speed of 6.6 meters per second. The construction of the wind farm was divided into 3 stages. At the first stage, under the project, 4 wind turbines of the German company Nordex were installed, each with a capacity of 1 megawatt, the installation of which began on October 21, 2013. In December 2013, they were taken into operation. At the second stage, 17 units of the same company were installed. At the third and final stage, work was carried out on the improvement of the power plant. In October 2015, the last 10 wind turbines were launched. In addition to the wind power plant, a 110 over 10 kilovolt high voltage substation Kordai wind farm was built with 2 transformers of 16 megavolt ampere and 2.4 kilometers of 110 kilovolt transmission line for communication with the power system. Next to each wind turbine allocated KTP 10 over 0.69 kilovolt. The units of the wind station are launched with a wind force of 3.5 meters per second, and when the wind speed exceeds 25 meters per second, the blades stop, otherwise the vibration will destroy the structure.
Wind energy in Akmola region. Nowadays in Akmola region, several projects are being implemented to generate electricity from alternative sources. One of them is the construction of a wind power plant in the Bulaksai rural district of the Arshanal district of the Akmola region. The total capacity of the wind farm will be 100 megawatt, while commissioning is planned for 2 startup complexes of 50 megawatt each in 2019 and 2020. It's expected that the commissioning of a wind farm will reduce greenhouse gas emissions by 200,000 tons per year, which exceeds emissions of more than 113,000 cars per year. After completion of construction, the wind farm will meet the needs of more than 10,000 families, thereby reducing the use of fossil fuels. During the construction, up to 300 workplaces are created and up to 20 permanent workplaces are created for maintenance and management of the station. Training and professional development of local specialists will be held abroad. The wind farm will be located on a land plot with a total area of 119 hectares, while unlike solar power plant, there is no need for complete fencing of the territory, which allows people to freely move around and graze cattle. In addition, a project for the construction of 120 megawatt solar power plant is being implemented in the village of Khabambay Batur, Tselnograd district. The design work phase has now been completed and preparatory work has begun on a 300 hectare site.